CNT120, Chapter 1, we're on the section on networking hardware. So we're going to talk about some of the hardware that is involved in networks. One of the first ones here we mentioned is the switch, which we talked a little bit about with our topologies. That's why I like to give you a little history so you can see the evolution of the topologies. The switch is your layer 2 device. Again, that'll make more sense as we do OSI model. It is there. It is there as a connection device between computers, like so. As traffic moves through, it starts paying attention to, oh, this MAC address is on this port. Oh, this MAC address is on this port. Oh, this MAC address is on this port. And it builds a table. So ultimately, you can then do, as we said before, when computer A goes to send to computer B, it literally just makes a connection between those two. Meanwhile, C can send to D. And it's able to do that because it knows that MAC address is on that port, so I'm only going to pass it out that port to that computer. That's what your switch is able to do, which is why your networks today are fully switched. I remember back in around 2000, it was a big deal for a company to be migrating out their hubs and putting in switches. We even had a gentleman come from the Navy depot at the time and talk about their plan to migrate the hubs out and the switches in, and we were all kind of like googly-eyed. We're like, oh, wow, that's pretty cool. So yeah, it was a process, migrating the hubs out into switches. Here's a whole bunch of different style switches, different port counts for a number of different nodes. Even here, having extra blades of ports, and then also up here, this is your advisory engine, the brain of the thing, and redundant power supplies and so forth. Your network card, this is the device that connects, that's in your computer, if you will, that gets you access to the network. This is the piece that's sending data from your computer to the network, or getting data from the network and bringing it into your computer. Pretty much any device that connects on a network has a network interface card. And depending on the type of network you connect to is the type of network card it is. Well, once upon a time, you might have a token ring NIC to connect to a token ring network. You might have an AppleTalk NIC to connect to an AppleTalk network. You might have an Ethernet NIC to connect to an Ethernet network. Well, nowadays, we pretty much all use Ethernet networks, but I still might have two network cards on my computer. I might have an Ethernet NIC to plug into my Ethernet network, and I also might have a wireless card to connect to my wireless network. So I might have two network cards in my computer. Even your cell phone does as well. There's one for your cellular network and one for the Wi-Fi network, your wireless network. So it's not uncommon to do that. So network cards, some of these are really old. Here's an old coax bus right there, coax bus Ethernet NIC right there. Twisted pair, fiber optic. Here's a USB adapter. Here's one that would slide into an old laptop using the PCM-CIA port. Here's ones you can wireless for connecting in USB or snapping in your motherboard. Here's actually an older, that one right there, not ISA. That might be ISA. And then here's your PCI Express right here. Here's one for a printer, sliding in to give your printer capability to print. Here's an IP phone with the NICs built in, allowing you to plug it into a network. Here's a computer motherboard with the NIC built into the motherboard in the computer. That's pretty much what most things are now. When you do the hardware class, PC hardware class, you start looking at slots on the motherboard. Here's a really old ISA slot for connecting a network card. Here's a PCI slot, and then there's even PCI Express, which is the kind of the common one that would be used now if it's not integrated into the motherboard. And then here's ones that are USB slots that I can plug into. And then if I actually have a network port over here, that's integrated to the motherboard right there. Here's old school laptop PCM-CIA slot. Here's old school ISA NIC with coax bus. Here's an old ISA and PCI. Actually, these are PCI right there. Those are PCI slots there. Then here's some PCI Express for wireless and wired NICs. USB for wired and wireless NICs. PCM-CIA for wireless as well as wired. Okay, so lots of different varieties over the years to connect your device into a network. Router's a device you might only have one in your whole network. You have one at your house. I have one at my house. That is the piece of hardware that's connecting my devices on the switch to my ISP, or my wireless devices connecting in to the ISP. That's this gateway, if you will, between my network and the ISP. This might actually be a gateway between two cities, Philadelphia router to Harrisburg router kind of thing. Okay. This is going to serve the purpose of moving data in and out of my network. It's used to connect my LAN to my WAN, if you will, my LAN to my ISP. And these are going to be able to process data at a higher level using more intelligence of like, yes, you can go there, or no, you cannot. That's what the router is going to do for us, along with some other functions. Like your router at home is able to, your network in a box at home has a DHCP server built into it, those kind of things to give additional functionality to your network. So again, if I bust apart my router at home, if you will, remember it's really a network in a box. So the circuitry in here that's connecting my switch ports and my wireless out to the ISP, that's this right here. That circuitry right there connecting the WAN port is my router in my network at home. It can connect two different Ethernet networks, but it can connect LAN to WAN. In our case, it's usually LAN, Ethernet LAN, if you will, to the ISP, whatever technology they happen to be using. It operates at layer 3 typically, so it's reading IP addresses at layer 3, so it's able to make more educated decisions, if you will, on where things go and where things move. It can also deal with higher level protocols too to filter traffic. It can do that as well. It is going to be slower than a switch because it needs more time to process all of that. It has to read more data, so it's going to take a fraction of a second longer to read it and make a decision to move it on than the switch will. So that's why there's typically like one router at the edge of your network to process the traffic coming in and out. If I were to crack it open, again, don't do this at home, but this is what you kind of see. It's basically a specialized computer. And actually, you can load onto an old computer. If you put a couple NICs in an old computer, you can load on a Linux-based operating system and turn it into a router. That's its own little project, by the way. But you can do that. That lets you know that it's just basically a specialized computer. These are the kind we're used to at home. These are kind of older now. And this is the kind you're used to in, a business or networks like we have in our lab room, or this guy right here. This is one of the more recent ones that we use in our lab room. And as I look at them, I'll see some LAN ports and some WAN ports, kind of the in and the out for my network. That brings us to the OSI model. I will pick up there on the next podcast.